Thank you everybody for coming. Today we're going to answer the big question, is Microservices SOA done right? But before we get started, I just want to let everybody know that this presentation will be on YouTube. It will also be on SlideShare. And you can ask any additional questions on the Apigee community, because we all know how much people are passionate about microservices and the diatribes. Just a quick introduction, I'd like to introduce Matt Stine. He's a senior product manager at Pivotal. And he's also the author of the book, Migrating Cloud Native Application Architectures. Myself, I'm the head of developer programs, and I'm the author of, no, I actually don't have any books, not famous like this dude over here. Pivotal has helped a lot of companies. These are just a few of the companies that have helped out with microservices. Same with Apigee, we've helped companies with microservices as well. Some of them are well-known companies such as Burberry, Bellycard, and a few outside of US too. So I got a question for you, Matt. What do you recommend for people to fix their last SOA deployment?
I don't know if that fits in a joke.
That doesn't fit in a joke. Well, I think it's just more services. Anyhow, so let's first, when we get to the first topic, so what do you think about, what are some of the best practices for microservices? What one thing for them to know?
Sure. So one of the first things that we thought about talking about was this idea that you should think in graphs and not layers. And if you look at your traditional enterprise monolithic application, we tried to create modularity, and we tried to divide responsibility into different layers like data access and services and MVC and so forth. And the interesting thing is that there's actually a graph hidden inside that application already as well. You just couldn't see it very well because it's hidden in a big strain of method calls. And so then we started talking about service-oriented architecture. And we kind of took the layered concept and we spread it out a little bit more in that, okay, we create these services, but they're all sort of jacked into this central enterprise service bus. And sort of the going wisdom I remember from one of the very early SOA projects that I was involved with was, you build your service, and as long as you can jack it into the ESB, everything's going to be fine because the ESB is going to take care of everything for you. And it still looks kind of layered, but not quite. At the same time, that graph is still present inside this slide as well. It just happens to be hidden inside the box. And so when we get to these microservice architectures and people started putting them up on slides, you saw these kind of nasty looking Death Star charts with a bunch of services around the rim and a bunch of interconnections that were out there. And these were some of the ones that I borrowed from a presentation that Adrian Cockcroft gave several months ago. But you see this really nasty complexity, and so the question that you immediately ask is, how is this better than what we were doing? Because I could kind of make some sense out of the layers in the monolith, and I could still kind of make some sense out of the ESB diagram. But when I see this, I wonder, how in the world am I going to manage this? And the thing that you have to start to think about is, all this is really doing is just making the complexity that you already had in your architecture and in your business logic visible. And what the other techniques were doing in many cases were actually hiding it inside of a box. It was still there. And so the complexity hasn't changed. We've just made it visible, and now we're, in a sense, forcing ourselves to deal with it. We've made each service a little bit more responsible for its own destiny, in that, okay, I can't just jack into a single point and that ESB is going to make everything okay. Now if I want to talk to this service or that service or that service, I'm responsible for making that happen. But at the same time, I'm now no longer sort of beholden to this central point of authority that anytime I need to make a change, I have to go to them for permission and try to somehow massage that complexity in one place, as opposed to now, hey, I need to talk to another service. I just go talk to it. I'm responsible for managing that connection, but it's not. It's no longer something that's going to hold me up. So
Yeah, and I think it's like, you're telling people to essentially embrace the complexity that you already have.
Yes.
But now the fact that it's split out into services, you can actually change the logic, and you can actually, in a more agile and decentralized fashion, be able to change and add additional services, right?
Exactly. The goal is getting to a point of each service being able to act autonomously, as opposed to, we're going to this central point of enterprise architecture authority to get decisions on how connections can be made. And we'll talk more about that, I think, as we get further into the presentation.
Okay. And by the way, if you want to find, if you go online and you search Netflix, maybe Network Microservices, the graphs like these are probably on their blog.
Sure.
Amazon has we have a blog on Apigee. We'll probably put some of those pictures on here as well. And you can actually find one on Amazon circa 2008, and it's even crazier than any of these.
Yep.
What else? What else should we think about for microservices?
So when we embrace that complexity and we start decentralizing, sort of the connection and collaboration management, we realize that no microservice can really afford to behave like it's living on an island. It needs to be very aware of the fact that now I'm living in this new world of distributed systems. And so if you take a look at even a very simple system, let's say we're going to build 2 whole microservices, and we're going to have a user interface that's going to connect to those. So this user interface is dealing with some sort of idea that we've got customers and we know where they are, and we've got some sort of stores that we're keeping track of and we know where they are, and I should be able to find what stores are nearby me. Very simple system. But as soon as I create a system like this, I run into this whole list of distributed systems concerns that we have here on this slide. So I've got now 3 things that I've deployed, and maybe I have some configuration information that I want to be able to share in a consistent way across all of them. How do I do that? And then I have another concern of, okay, I now have 3 different things deployed. Where are those 3 things? And of course I know I'm not going to end up having just 3. I'm going to have tens and maybe eventually hundreds of these things. And as I scale up, that problem of, what is the address of the thing that I need to talk to? How do I get that information? Do I hard code it in the application? Do I somehow set up DNS? What do I do to solve that problem? And then once I know the address or addresses of a thing, because one of the reasons that we go to microservices is to support the ease of horizontally scaling different concerns. So it's not just that I talk to the store service and I find out that it's at this IP address. I might get back a list of 10 IP addresses. Okay, well great, I've got 10. Which ones do I talk to? How do I load balance across all of those different connections? How do I decide which ones are healthy and which ones are not healthy? We have these issues. And then obviously you're in a distributed system and you're talking over a network. And we know from looking at the fallacies of distributed computing that number 1 is the network's reliable. So we're going to have services that go down. We're going to have services where there's intolerable latency over a particular connection, and so we're going to need to think about the idea of fault tolerance. And if you think about distributed systems and failure in general, you know that the probability of failure of any node in the system goes up exponentially with the number of nodes you have in the system. So the more microservices that you build, the more likely it is that something's going to fail. In fact, you get good enough at this, the probability of something being in a failed state in your system starts to approach 100%. And so it's now no longer, hey, we're going to make our system so strong that nothing ever fails. It's now, okay, failure is going to be continually happening all the time. And we have to build a system that knows how to live in that world. And that dovetails really nicely into the idea of monitoring concerns. If things are failing, I want to know about that, but I also want to know, well, what is the behavior of the fault tolerance in the system? What is the behavior of the load balancing in the system as failures start to occur? Is the system making the right decisions? And if it's not, I need to know that so that I can take some sort of corrective action. So, and this is just a small list of the things that we need to start thinking about. So on the next slide, we take those 3 services and we start to take some patterns and apply them to solving these problems. The cool thing about distributed systems is even though they're hard, even though there's a lot of problems that we have to think about, a lot of the solutions to these problems are actually very well understood, and there's a lot of good literature that you can go read. And you can implement solutions to these patterns. So things like central configuration management, service discovery patterns, circuit breaker patterns, client-side load balancing patterns, all of these things are very well documented, in some cases implemented in open source, which kind of is a good segue into the next topic area.
And I want to talk a little bit about service discovery. The reason why things like ESB and traditional service discovery doesn't work is scale, right? When we start going if you start going from 10 services to 1,000 services, what's actually happening is the number of connections between the services is going up another exponential, couple orders of magnitude. So your service discovery and kind of understanding that you actually need to use almost web scale type technologies, right? So like, for example, Amazon Web Services, millions and millions of customers. You know why? Because they have a good developer portal, there's a self-service onboarding mechanism, et cetera, et cetera. You need these kinds of web scale techniques to bring them into the enterprise.
Yes, absolutely.
Which now talking about scale.
Right, yeah. So you see all these problems, and coming from an enterprise software background. So before I got into doing cloud native stuff with Pivotal, I spent a good 11, 12 years inside the enterprise building systems. And so I understand the mindset really well. And when we see, we have all these problems to solve, and we want to scale it out across a huge number of developers, the immediate kind of knee-jerk reaction is, we need to build enterprise architecture. We need to go write a bunch of documents. We need to disseminate those documents to a bunch of people and say, okay, you must build your architecture this way. And you have to make sure that as you code, you do this and this and this and this. And we're going to enforce that by making you, bring the decisions that you're making to a committee on a regular basis to get a rubber stamp on your design to say, okay, yes, this is actually compliant with the architecture before you can go forward. Obviously, that technique is not a web scale technique. It's not something that allows you to go fast. By definition, it actually slows the process down. So what you see these web scale companies doing is, instead of writing documents and building committees to approve architecture, they take the best practices and they take the decisions that you need to make well, and they push those down into frameworks that can be used by developers. And if you simply use the framework, then by default you're going to make a lot of really good decisions automatically.
So it's like the 80-20 rule. And I just want to continue a diatribe on this. So what happens is that these committees, you have the best engineers who are on the design on the enterprise architecture board. They review a service being created. They said, okay, you need to do X, Y, Z things before you launch a service. Mm-hmm. 1 month later, that particular service team launches those services and then come back to do a design review. Turns out things like monitoring is not done. And then the enterprise architecture team would say, oh, you didn't add monitoring. And then the team says, I didn't have time to add monitoring because it was too, I know we bought this tool, some vendor tool, but I didn't have time to do it. And by the way, it's in production, so I don't have any time. I got a next release, right? Yeah. And it just perpetuates this angst, right? And furthermore, it says that the service team would say, guys, come on, we need a framework. Well, the most experienced people on to build frameworks are in the review board, and they don't have time because they're doing reviews of microservices.
Right.
And so it's just perpetuates this perpetuates this pain, and just everybody then says, microservice is terrible.
Yep.
So
not that we've ever gone down this road before and said, if we just do all these things, then everything's going to be fine. And then we try to do all those things using the old processes. Yeah. And we create the pain. And instead of blaming the way we work, we blame the thing that we try to do. And so, microservices are going to be hated on equally as much as everything else that we've done, just because we approach it using the same line of thinking and the same way of working that we've done in the past. And we're talking a lot about technology today, but I tell people all the time that if you don't change your process, if you don't change the way you organize yourself to build software, you're never going to succeed with microservices, because it's literally a fundamentally different way of thinking from the ground up, both people and technology. But back to technology.
Back to frameworks.
So, and it's interesting to be talking about this, because I was just at Netflix yesterday talking about the future of some of the technologies on this slide. What did they do in building a substrate to be able to create microservices at scale on Amazon Web Services? Well, they didn't just go stand up a bunch of EC2 instances and throw some code in there and glue it together in an ad hoc way. They built, for all practical purposes, a platform with frameworks that you would automatically bring into the applications that you were building. And because you did that, the glue was in place to make these things communicate well. The glue was in place to do things like rolling upgrades of services, being able to scale things automatically in response to different metrics that are being gathered. But the really cool thing that they did was that they took these technologies that solve these problems and open sourced them. And so now it's not just, hey, go read the papers, go read the documentation of these patterns for distributed systems, but hey, here are some implementations that not only exist, but we know that they work at extreme levels of scale. Because if you look at the amount of traffic that's flowing through Netflix at any given point in time, it's ridiculous. And so we know that not only do these components exist, but they work at scale. So I'll take that back into what the things that we're doing at Pivotal to support the idea of frameworks. So I come from the Spring team at Pivotal, and if you're not familiar with Spring, it is probably the predominant enterprise Java framework in existence. It's been around for now over 10 years. And there's a huge number of people that have been doing enterprise software and enterprise Java all of that time and have baked all of this knowledge into the frameworks. But they were kind of hard to compose easily. You would go get a little bit of this, a little bit of that, a little bit of that, and try to figure out what versions were compatible and bring all that together. Well, a few years ago, the idea was hatched of creating this tool called Spring Boot. And what Spring Boot allows you to do is get convention over configuration for a Spring application and take all of those patterns of best practices of how to use Spring and how to use enterprise Java, start up a project in a few seconds and start writing your business logic. And all of that stuff is there, from the dependency management to the versioning to the configuration to production readiness, things like metrics and health checks. That, the enterprise architecture team said I needed to add this stuff. Well, it's already there out of the box. You just kind of point whatever tool that you have for aggregating metrics or logs or so forth at these endpoints, and it will happen to just work. And Spring Boot itself has kind of taken the world by storm. We've got some statistics here that if you look at the growth, and this is just downloads from Maven Central over the last year, and you can see that just in pure Maven downloads alone, we've gone from somewhere around 1 million downloads to 3 million downloads. So pretty rapid, crazy growth there. So Spring Boot's great. It gets you your template for your single microservice up and running in a very easy way. But what we wanted to do in addition to that was take those distributed systems patterns and take what Netflix created and make it work just as easily. So, can I make it to where I, annotate my Java application with something about enabling service discovery? So we have an annotation called Enable Discovery Client. And just by adding that annotation and adding the appropriate Spring Boot starter to my Maven or my Gradle file, I can now register my application in Eureka and discover other services in Eureka. And let's say I wanted to use circuit breakers from Hystrix, adding an annotation to enable circuit breakers, and then going to different methods in my code where, hey, I'm going to go make a service call to this other microservice. How do I protect that with a circuit breaker? Well, I add another annotation to that method in my Spring Bean, and now I get circuit breaker behavior wrapped around it. And so all of that behavior is now wrapped into Spring Cloud, which I think of, Spring Boot is convention over configuration and opinionated single microservices. Spring Cloud is that same convention over configuration and opinionated distributed systems patterns. And so at the end of the day, I should be able to go to this next picture here and create that diagram that we had that was sort of technology agnostic before, and have all these patterns now have implementations of them. Central config server coming from Spring, service discovery coming from Eureka, load balancing coming from Ribbon, circuit breakers coming from Hystrix. And all of that stuff is easy to compose into Spring. If you're already familiar with the Spring programming model, then you learn a little bit about the pattern, you add the appropriate dependencies and annotations, and away you go. You're now using proper distributed systems patterns in an unintrusive way. And what are you doing? You're back to focusing on your business logic. What is the thing that I'm trying to build that's going to give me a competitive advantage? It's not all these patterns. Everybody has to do that. If you're going to do microservices, you don't have a choice. So let's stop focusing on that, get that from a framework, and start building, real code that's going to give me a competitive advantage.
And there's just so many. I really got to say, the last few years, there's been so many frameworks that came out, not tools, but frameworks that came out, right? So a couple of them, Amazon Lambda. It's really coming from within Amazon. We had this program called a framework called Codigo. In fact, we had a team called Builder Tools, right? A team that builds tools for builders. And a lot of this kind of stuff is inspired by Lambda. So it's not only way cheaper, but it's also, you get all the monitoring and stuff out of it. It's the 80-20 rule, right?
Sure.
gRPC, this is actually this is mainly from Google, but it's a collaboration of other companies like Square. They've created another framework that's super high scale, extremely efficient for microservices. Apigee has a whole bunch of tooling and framework as well. And last but not least, if you don't like lock-in, we got Cloud Foundry, right? So there's a lot of good options. There's no excuse for people to not have a build a tools team and have their own framework.
Absolutely.
Because we're a little bit short on time here, so maybe we talk quickly about this, and then or do you want to skip this?
Yeah, we can run through it really quickly. I mean, there's a lot of consternation out there about, okay, well, we're talking about microservices. Maybe we put the cart before the horse, and we don't even know what a microservice is.
Yeah.
And there's a couple of good definitions out there that we can go through pretty quickly. This is Adrian Cocroft's definition again, and I really like it because it talks about service-oriented architecture. It doesn't say, oh, that's an evil thing that we don't talk about anymore. But he kind of qualifies it with these kind of bookends of loose coupling, which is all about the life cycle. Can I deploy services in an autonomous way? And one of the ways I get to that is through this idea of bounded context that I have a couple of interesting slides about here. But generally just this idea that, hey, these things are probably smaller in granularity than what my SOA services looked like in the past.
Yeah.
Okay.
Being pragmatic about it.
Exactly.
Right?
Exactly.
Not every single service has, the word bounded context has many different meanings.
Sure.
And you can never truly get to true separation of bounded context.
Sure. Yeah. It's difficult. But the idea that, hey, there's like a magic number of lines of code that if you go past that number, you're no longer a microservice, kind of a silly conversation. But the whole idea of bounded context, very quickly, is the idea, again, coming from an enterprise mindset, one of the things that we often do is we try to create one data model to rule them all. Yeah. And if everybody just uses that data model, then everything's going to be okay. But if you've ever been on one of those projects, you know exactly how successful they are. And part of the reason for that is we can't even agree on what all the words mean. And so the idea of bounded context is take your your model and shrink it down. And I think can we go to that slide right there? Yeah. We take the model and we say, okay, well, people from this context think about the words this way. People from, say, product catalog, when they think about movies, they're going to have one view of the world. People from, say, an inventory context, they're going to think about movies in a different way. And so allow them to do that. Say, hey, you get your data model, you get your data model, and then in the API layer, which I know is important to you, is where we start to define, hey, how does one kind of movie translate into another kind of movie? What are the rules for communicating between these different bounded contexts? And we create contracts for that sort of thing. But the one thing that you have to be careful about is, where does the data live? So I might break my services down and have them all talking to a single database.
So this is what kind of pattern is
this? This is an anti-pattern. And this is the thing that I started seeing come out. I was like, okay, well, I've broken all my services down, and I'm talking to this database. How am I going to manage all those connections to that database? I was like, whoa, hold on. What are you doing? Because if you look at this, it looks like I have bounded context, except, hey, we're all talking to the same tables. And as long as we all agree, I'm only going to talk to my tables, you're only going to talk to your tables, it works. But then you don't give me something I want in time. I say, well, hey, your table's just right over there. I'll just write a quick join just this once, and it'll be okay. And then I break that first window, and then they're like, oh, you can join tables in the database? I didn't know that. And before you know it, you've created that spaghetti code, except now you've shoved it down in the database layer, and you wonder why are all my microservices not as decoupled as I want them to be? And so this is kind of where the whole idea of the database per service pattern comes from. And it doesn't necessarily mean that you're talking to separate physical clusters, but that, hey, service X has its own guarded kind of schema. If you're saying a relational database, service Y has its own schema, service Z has its own schema, and now you really know that everything's coming through the front door of the API. And then this starts to enable you to do other interesting things like, hey, the shape of my data isn't really good for a relational model. Maybe I want to use a column store. Maybe I want to use a graph database. Maybe I want to use a document store. Or maybe my read-write patterns are driving me one direction or another. Because everything is in a bounded context and because everything's hidden behind an API, I can now start to choose different data store technologies that are a better fit for a particular slice of the problem that I wasn't able to do before. And if you take this to its logical conclusion, if I make a mistake, I should be able to swap out my database and everything should be fine. So
the next great database technology, right?
Exactly. And nobody should ever know the difference. I could swap my database once a week if I wanted to. I wouldn't recommend that you actually go do that, but I'm just saying, that keeps that decoupling truly there. So if everybody's only communicating through APIs, then you really can autonomously make architectural decisions within the scope of your bounded context, and use right fit technologies as opposed to let's force everything into a single design, everything into a single architecture.
So for example, here, and you're doing a commerce, your service X could be an ordering database, because databases like Postgres are transactional, right? You can use, doing all your counters, doing it in Redis, it's a perfect place to do it, right? And then if you're doing things like product recommendations that has web scale, you can put it in MongoDB, right? So you get the best of both worlds.
Absolutely.
All right, so now I'm going to get into a little bit more of the technical screw-ups that people usually get into, right? And then the one of the killer is performance. And to really understand performance of microservices, whether it's availability or latency, it's really about understanding math, namely joint probability, right? So let's take an example of a microservice, a series of microservices. A call might come in from, let's say, a mobile client. It needs to make two calls in series, right? Calls maybe, let's say we're doing an order calculation, right? It might call a shipping service, then it would call the tax service with both the shipping price and the product prices. And these services itself may be making calls as well, and they might be making calls in parallel. So the question is, what's the latency and availability? it actually is really, really hard. Because what happens is when you're designing your services, all services try to design themselves they're designing themselves in isolation at first because they're trying to do it in scale. And they always try to design for high availability. So let's take an example of every service tried to design itself actually, just give me a second here. Let's talk about availability. Let's assume every single service here tries to design themselves for 99% availability.
Okay, that sounds like a good
plan. Number,
yeah,
right?
Yeah.
But when you actually put it together, if any of these services fail, then you would decrease the availability. So actually I made a mistake here. It's times 6. The true availability of this is actually 94%, not 99, just from the nature of how it's done. Latency is even harder, right? So let's say example, the latency of each of these services is 100 milliseconds, right?
Okay.
But you have to, how you calculate the latency depends on, it depends on the service, it depends on whether you're making the calls in parallel or if you're making in serial. So actually, the latency of this particular graph is 500 milliseconds in total. Calling these in series and then calling these in parallel. But what's even harder, saying averages are great, but if you have like a huge percentage, if you have a percentage, let's say the top 1% of the slowest 1% has a poor experience, that's really bad.
Right.
And if you tell the COO or CIO, hey, 1% of your orders are going to take 5 seconds to place, he's going to go crazy, right? So and you look at this from a 99-point TP99 perspective, assuming that these are actually statistically correlated, the time it will take for this API call is not 500 milliseconds, it's 5 seconds, which people usually abandon their carts.
It's kind of a big deal.
It is a very big deal. And why are they statistically correlated? Well, in the case of ordering, actually more often than not they're correlated, because in the case of, let's take a case of ordering, the latency of each of these services usually depends on how many items are in the bucket.
Right.
So how many items are how much you charge for shipping is usually dependent on how many items. How many tax calculations you do is dependent on the number of items. So they're usually, in my experience, statistically correlated.
Yep.
All right, so that's really hard. So how do we actually do that? Well, there's 3 techniques I'd like to kind of share on how do you improve latency of these microservices, especially if you have these complex call graphs. One is caching, then the other is retry logic / fault tolerance, and then last but not least, distributed tracing. Okay, let's go through the first one. Let's take an example, caching, right? Let's in a simple request cache. Let's say, for example, the first service is caching the 2 other services calls that's making in parallel.
Okay.
And what this actually does is that, I got the slides mixed up. In the scenario that there is no caching, your availability is going to be 97%, your latency is 2 milliseconds, and your TP99 is 2 seconds. This is not good, especially your TP99 availability. But if you have 50% caching, just even in the cache hit rate of 50%, you increase your availability by 1%. Your latency is gone down by 50 milliseconds, and then also, more importantly, your TP99 is going down as well by half a second. So this is just from that. Getting better. But better yet, TP99 means the percentile. So that means that the slowest 1%.
Okay.
Right? It's the slowest 1%. But what happens if we have a cache hit rate of 100%? And this is actually a very common pattern. What happens is that these very individual downstream services pre-computes all the potential answers and pushes the data up into the service that needs the data. It's a separate pattern, right? And if you do that, suddenly your availability now goes up to 99%, which is great. Cool. Your latency is great, and then your latency and your slowest 1 percentile is the same as the first service, right? 1 second. And so when you put them all together, when you put all these things together, you suddenly start being like a combination of, 100% caching plus a combination of, request caching. You suddenly increase the performance. You decrease the latency. You decrease both from an average but more importantly from a TP99, and then you also increase availability. So some of the things that Apigee does to kind of help you around that. And there's a lot of frameworks that do this. Usually what happens is, sorry, give me a second here. One of the things that we have is a gateway. So it's a very common pattern to put a gateway in front of your microservices to protect your service. And what we've done is that we built in a cache, right? By caching at this layer, the very highest layer, you can not only improve your availability percentage and reduce your latencies, but more importantly, you're also reducing the number of calls altogether. So you're actually saving a lot on infrastructure.
Yeah.
50% cache hit rate over here equals 50% lower cost in your infrastructure. So caching all layers is a good idea. But it's not just important to have the caches, but you have to know what the hit rates are.
Sure.
So getting analytics that out of the box that Apigee has, you can kind of figure this out. This is a company called GLH Hotels, and you can see, in the beginning of the days, they're getting around like a 75% cache hit rate. That means they're saving 75% of infrastructure costs and also getting a lot better latency. The other thing that we have is a product called API BaaS. So this is based on Apache Usergrid, and what it is it's a backend service that combines the best of Cassandra and Elasticsearch and puts it behind an API.
Cool.
So instead of you having to spin up your own Cassandra server, muck around with all the indexes, which developers probably get
Stuff's
wrong.
not easy.
Yeah.
And especially not easy to get it right at production, and especially not easy to get it right in production at scale.
Yeah. And then on top of it, put an API layer on it. It's a real pain in the ass, especially for services. So we built this backend service out of the box so you can essentially get micro data services almost for free. You don't have to have a special DBA to do it.
Cool.
And actually what we've done is that so you can create many microservices but using the same Cassandra and Elasticsearch cluster, because what we've done is that we've virtualized, as you said, you don't necessarily have to be talking to separate clusters. We're talking the same cluster, but we've done a lot of work on virtualizing the cluster itself.
Nice.
Okay, so the other kind of technique that they have is cancellations, timeouts, and retries. So assume that these services have 99 percentile availability. Okay. And then, as we said before, if we had six services, then your availability drops down to 96%, right? Well, if you just simply add a retry logic in your application, then the probability of a failure call reduces by 3 times. Mm-hmm. So what ends up happening is that you have your end availability of something of this sort bumps from 94%, all the way to close to 98%. Just by having retry logic.
Yeah.
But what's the danger of retry logic?
Well, what happens when I just start banging on the thing I'm retrying, I guess.
Exactly. So you can't be dumb about doing the retry logic. You need some sort of things like exponential backoff, things of that sort, so that you don't create self-inflicted denial of service attacks.
You got enough people attacking you, you don't want to attack yourself.
Correct. Yeah, exactly. And so there's a lot of tools that can actually teach you how to do this. So we have like Circuit Breaker, Hystrix. Talk a little bit about RxJava.
Yeah, so RxJava is a neat technology that takes the idea of the observer pattern and makes it very easy to use in terms of instead of we're going to go out and can I deal with the concurrency of I'm going to attack the service graph and go to this thing and then this thing and this thing, and I realize, oh well, these things could be done in parallel. So in Java, what I'm going to do, I'm going to create a bunch of threads and do stuff. Well, that's kind of not great. So then I can get into futures and completable futures, and those APIs are decent. But again, as you get to a more complex graph, they get very hard to compose the code in a nice way. And so one of the things that RxJava allows you to do is to take those patterns for functionally composing calls in a parallel way and actually doing it in a way that feels very much like sort of the Streams API that you get now in Java 8. And in doing so, instead of, okay, I'm going to go do this and I'm going to go do this, I'm just going to fly a bunch of calls out there, and then as things complete, code's going to react to that completion, and then I can take that result and compose it with another result as it comes in, and take that and hand it to something else, and it becomes much easier to do that, but you also don't get yourself buried into things like callback hell.
Okay, yeah. And this is important because making calls in parallel drastically reduces the request time. Right?
Exactly.
And I actually tell people, like, if you really want to understand a lot of the best practices, just go open the Amazon Web Services SDK. It has built-in. You could just take a look at the code. It has built-in. Exponential backoff because they don't want their system being denial service attacked. Built-in authentication. There's just take a look. It's a great way to actually understand how to make network calls, and cool. It's free. All right, and then the last thing that we talked about is monitoring. So it's not just important to monitor the service themselves. I think the true holy grail for microservices monitoring is understanding the entire call graph across all the services. And the best project I've seen out there, I mean, it's based on Google's Dapper, is a product called Zipkin. You know what? But unfortunately, it's open source. I just wish somebody would be productizing this product.
Yeah, well, we're working on that. So, one of the principal maintainers of Zipkin, who is, at Twitter, he's been in a lot of places. Adrian Cole. He recently came to work for Pivotal, and he's been spending a lot of his time recently, getting Zipkin towards, sort of a true open 1.0 release, and working with a lot of different companies that are doing microservices and understanding what their needs are, and understanding things like there's the whole open tracing API discussion that's going on. But in addition to all that, like we've taken things like the Netflix OSS stack and made it available within Spring and made it into turnkey services on top of Cloud Foundry, we're going to be doing the same thing with Zipkin and making it very easy for your microservices running on Cloud Foundry to just participate in distributed tracing, and then take all of this data and sit it side by side with the other metrics that you're interested in that are coming out of your applications, as well as things like your circuit breaker metrics, and kind of really look at from sort of a, it's kind of a trite phrase, but the idea of a single pane of glass that you can look through and see all of the behavior of your system. When you have 2 or 3 applications, that'd be great, but not that big of a deal. You have hundreds of individual microservices running now, being able to go to one place and understand the aggregate behavior of that distributed system is absolutely huge. And
so, the last kind of like major tip that I think this is actually the beauty of microservices is the idea to create consumption-focused APIs, right? Not create these one-size-fits-all. And what I mean by consumption APIs, they have other names around it. Sam Newman calls it backends for front ends pattern. Netflix calls them experience APIs. And the idea is to create a service geared towards the application, right? And then this service makes service calls down to its downstream services. And because these downstream services are much more granular, you can kind of pick and choose which services to compose. And the pattern, and the reason why I think this is probably the best, this is the best example of agility through microservices, is because this actually scales, right? If you have just one centralized team that's managing the APIs for all the mobile teams, you suddenly have this choke point of this one central API team.
Yeah.
And you try to create this one API to rule them all. You don't even know what the requirements are because the mobile apps are not built yet.
Well, you just said it again. You said something to rule them all. We already said that that's bad at the database layer. As it turns out, it's bad at the API layer as well.
Exactly. And doing the microservices, you let for example, the mobile team actually go create their own service themselves.
Yep. And the cool thing about that is it's really just good old-fashioned object-oriented design principles kind of percolated up to the architectural level.
Yeah.
You've got the whole solid design patterns. One of them is the dependency inversion principle.
Yeah.
This is just the dependency inversion principle all over again. Instead of me being dependent upon lower layers, I make lower layers dependent upon me. And so the thing that's in the driver's seat is the team that's building the experience, as opposed to a bunch of other microservices teams being in the driver's seat, and I'm kind of up here as the person trying to build this mobile application, trying to keep up with all these things going on, and I can't really do it. And so building this layer to insulate my, say, iOS application or Android application from all of that craziness going on makes me able to do a lot of things that I couldn't otherwise do.
So why don't I just give a real-world example to tie all these things together?
Cool.
One of the companies that we work with is Belly. So Belly Card is if you go into a lot of the stores, especially in the US, you will see a loyalty card, like a mobile loyalty card with a tablet. It probably, if you're in the US, it's probably built by a company called Belly.
Okay.
And they started off with a Ruby-based monolith, and they wanted to go to microservices as well. So they created essentially a lot of these exposure-focused microservices. And what they ended up doing is that within they use Apigee as for its API management. What they ended up doing is creating API, client-focused APIs.
Okay.
Right. And this is great because, for example, last year they launched a new app for their merchants. Right.
Okay.
And the beauty of this is that what they were able to do is that within the Apigee platform, they were able to create a bunch of microservices geared towards that particular, especially experience APIs, geared toward those particular ones. So you can see here there's an iOS business. They probably have another one, iOS Android, for the Android apps. They've really kind of broken it down. And the beauty is that these folks never had to, the way that they constructed it, there's multiple ways to build microservices, but the way they constructed it is using Apigee's combination of JavaScript policies to do some orchestration. The beauty of this is that they never had to bother the teams, the team that's maintaining the monoliths as well as the smaller microservices. So the mobile team was able to get a launch done without bothering the back end teams.
Wow, that's nice.
Right. And there's so many different ways. There's so many platforms now for doing experience APIs, lightweight orchestration-focused APIs. AWS Lambda is probably the best for Node, and in my opinion, for Node, Heroku is cheap.
Sure.
Heroku is best for Ruby, and if you don't like vendor lock-in,
absolutely,
Cloud Foundry is definitely the best in my opinion.
And pick your language to put on top of it.
Exactly. Yeah. All right.
So, we've kind of talked about a lot of cool things that Pivotal's doing. We've talked a lot of cool things that Apigee's doing. Is there something that we could be doing together to actually really support companies that are trying to adopt microservices?
And yes, we can. So actually today, we'd like to talk, I just want to give you a preview of the Pivotal Apigee integration.
Cool.
So the way that works is that we're in concert with the Cloud Foundry Foundation. We're both companies are supporting Cloud Foundry.
Okay.
And what I'm just going to show you how it works. So the API calls, when they hit something called the Go router, what happens is that the Go router would call Apigee to find out whether or not it should let the API go through and do all the mediation transformation, and then send it to the application, which is built on Spring Boot. So you get the best of both worlds, the the monitoring frameworks and the mediation and the
Cool.
From Apigee, but then also all the goodness of Spring Boot. Now, just mind you, this architecture right now that is going to go into beta very soon, and we're going to present it at Cloud Foundry Summit, is for experience APIs. APIs at the very edge.
Right.
And we have there's another phase 2 for our project that will be using a product that we call the Micro Gateway,
Right.
which is an embedded gateway that will probably live just inside the router or on Spring Boot. We're still going through the design that you don't have to do any external calls, so you don't have potential latencies over
Cool.
here.
Got it. And the thing I like about this one is that, if you're already a Cloud Foundry user and you're already familiar with the idea of service binding, using this service ends up being very similar in that now you have not just your back-end data services that you're binding to your app, you now have these things called route services that you're binding to your app. So to actually take advantage of this, you're not really changing what you're doing with Cloud Foundry at all. You're building your app the same way.
Yep.
You're deploying it the same way. You're just binding an additional service to it, and all of a sudden, all of this experience API management stuff that you can do in Apigee Edge just becomes composed in with your existing applications. It's really powerful.
And the beauty of this too is that if you're like, let's say you're a Cloud Foundry user and you don't want to use Spring Boot because you have a team that cares about Golang, right? So,
Right. Yeah.
you can go find, you can still get the benefits. You can mix and match. It's all about choice, getting the right technology for the right people. You would obviously have to find a product that is similar to Spring Boot for Golang, and I recommend gRPC from Google. They're pretty good.
Mm-hmm.
But yeah, it just gives you the flexibility to do that in an open and distributed manner.
Yeah, very cool.
Just a plug, both Pivotal and Apigee will be presenting at the Cloud Foundry Summit. And even if you don't use any of our technology, check this out, because cloud computing is really like our water. It's like our environment, right?
It
and
is.
we have to take good care of it. And this is the one company, this is the one organization that is doing so, in my opinion.
Yeah, and the cool thing about CF Summit is you bring together technologists that are building the technology, but you also bring together technologists that are using the technology and talking to each other about not only how we're doing things, but how we can do things better in the future and drive the technology forward in a way that benefits everybody. So it's a really great place to meet up and to collaborate.
So just closing. Think graphs, not layers.
No microservice can afford to pretend like it's on an island. You're in a distributed system.
Think frameworks, not enterprise architecture meetings.
Sure. Make sure that you understand the math behind the performance of your services, because you're not going to be able to defeat the math. So understand it and be able to work within it with caching and retry, circuit breakers, all these things.
And think experience APIs and not one size fits all.
Yep. And don't forget to come to and check out Cloud Foundry Summit.
Okay, so we have a few minutes for questions. So one question that was asked actually was, especially like for latency sensitive services, especially the ones that are lower down in the call graph for these. One question was, why is it important to use a micro gateway instead of a centralized gateway?
Okay.
So
Yeah.
any thoughts on that?
Well, I mean, my main concern with centralized gateways versus micro gateways is, it's similar to all of the other centralized concerns that I think about. Whether it's a centralized database or it's a centralized enterprise service bus or anything else.
Yeah.
When I put all of the things that I'm doing in one place, that place becomes very special. It becomes very important to the overall success of the architecture and the service actually being able to be delivered. So the more importance I place in one place, then the more critical it is that thing doesn't break. And what do we know is the one thing that breaks the most stuff in software? it's changing things. If we never changed anything and it worked once, it's probably going to keep working.
Yeah.
As soon as we start changing things, it's like, oh, we're not going to deploy 100 times a day because we can't even deploy once a month and not break a bunch of code. So when you have a centralized gateway, my fear is that people are going to take the thinking from, well, here's how I did ESBs, and they're just going to transfer that into a centralized gateway, where if the gateway logic is actually independent and has an autonomous life cycle, then I can keep those things loosely coupled. But I'm interested to hear your thoughts on it as well.
So that's also my recommendation. It's like if you're running, actually there's some practical reasons too. So the services that are deeper into the call graph are usually behind some sort of VPN or VPC. Sure. And what happens is that if you have a centralized gateway, you have to jump in and out, and they're usually divided up into multiple VPCs or VPNs. Sure. So if you always have to jump in and out between the VPNs, number one, you're creating security exposure risk.
Yep.
But you're creating a lot of latency too, especially when you're on multiple clouds.
And you're making your distributed tracing problem harder too.
Oh, ridiculous! Yeah. So what the recommendation that I give customers is that if you have APIs at the very edge, microservices and APIs at the very edge, then you use a centralized gateway because you want to manage all the traffic coming in and out of your microservices architecture.
Sure.
But within those API calls, use like a micro gateway that's distributed. Still use centralized management, so you can still have a central dashboard that's looking at all the microservices. Cool. But the actual logic of doing the like spike arrests or quota management will be done at the actual individual service layer. In fact, you want it so lightweight, these gateways, that you can deploy it on the same app server as where your you can deploy even on the same app server that your apps are running, and just proxy it that way.
Cool. And I've seen that pattern a lot too, so it's nice that you can work with Apigee that way as well.
Okay. So we have another question. Is microservices suitable for only applications in the same data center, or can be used across data centers? So they can definitely be used across data centers.
Sure.
They can definitely be used across even multiple clouds, like your internal cloud versus maybe your public cloud. But the one recommendation I would give is if you think about latency. Think about latency when you're doing cross data center stuff. So you definitely, anytime you're going to do cross data center, always put some request caching. Better yet, if you can, the downstream microservices, let them pre-compute the results and push them into some sort of NoSQL cache.
Sure, absolutely.
In the other data center.
And just make sure that as you're propagating calls throughout the graph, when you can, prefer a microservice that is co-located with you in the same data center to a microservice that's exactly the same, that's in another data center separated by a huge distance.
All right, so we have another question. Are there good frameworks or toolkits for all of this, especially for ISVs who build commercial SOA systems, then drop them fully into a customer's data center? Obviously, there's Spring Boot.
Sure.
This is one of the best for Java. For Go and some other languages, I really recommend people look at gRPC.
Sure.
And don't kind of like negate the other stuff like Jersey, etc. There's a lot of people who are building these great frameworks out there.
Sure, yeah, there's a lot of frameworks come out, even in the Go space. There seems like there's a new microservices toolkit coming out every couple of weeks.
Yeah.
But particularly from an ISV perspective, we work with a lot of vendors whose goal is to kind of apply the whole idea of cloud native microservice architectures inside the software that they're selling, and to the point of, hey, well, I'm going to drop my software that I'm building for customers on top of a substrate of something like Cloud Foundry, and then write the applications in something like Spring Boot. And I'm not actually exposing either one of those directly to the customer, but that gives me the ability to deliver software to a customer in a way that fits these architectural principles, instead of, hey, stand up this server, install this thing on it, follow this complicated list of 30 steps to manually wire everything up, and then maybe you can get the software working. Now it's, hey, drop a Cloud Foundry in your data center through this automated mechanism and switch the software on, and you have it up and running, as opposed to the old patterns. So we're doing that with a lot of companies these days.
So one question is, how do you handle securing your endpoints and securing your microservices endpoints? My personal recommendation, this is very biased, the technology that you want to handle your endpoints for going outside of your data center into your data center should be the same as the technology of securing API calls within the data center.
Okay.
Here's the reason why. Because what happens, I find, is that a lot of services, once they get created, even the downstream ones, suddenly a business team realizes, crap, this is an amazing service. This can bring a lot of business value. We should actually expose it to everybody outside. But then if they use a separate, secure technology that they use to secure internal traffic, let's say VPN or SSL certificates, then suddenly they can't do it because it's a totally different technology.
Sure.
So, for example, what I mean by that is, like, for example, if you do, if you use Apigee, you can use our centralized gateway to do OAuth between the services outside of your company, applications outside of your company talking to your service, and within the services themselves, you can use like a micro gateway. Or actually, Pivotal even has OAuth capabilities within Spring as well, right?
Yeah, exactly. One of the things that I was going to mention is that if I'm building my application using Spring Boot, and I'm using things like Spring Security and Spring Security OAuth, and I didn't anticipate this service going outside the firewall initially, but maybe I do. One of the cool things that we have also in Spring Cloud Netflix is integration with Zool, which is a great way to handle proxying concerns and do things like, I need to now apply my edge security concerns to that service. Well, because that service is already a Spring Cloud application and it's already using OAuth, we can put Zool in front of it and say, okay, now we're applying these edge security concerns and forwarding the appropriate context onto the application. And it really doesn't know, am I being used by an outside customer or an inside customer, because Zool's hiding that concern. So similar to what you're describing, there's a few different ways of managing that. But the idea of obviously keeping the authorization and authentication concerns in one place is a huge benefit for many, many reasons.
And make it self-service. Don't force another team to deploy some configuration to get them access to it.
Right.
All right. Circuit Breaker and Cloud Foundry only works for CF native microservices, or can be leveraged for external services that live outside of CF?
Yeah, that's a real easy question to answer. So when I say circuit breakers in Cloud Foundry, there's really actually no such thing. The circuit breakers are actually code that lives inside of your application. And for all practical purposes, that code isn't even aware that you're making service calls. That code can be used to protect any logic that may or may not fail. It just happens to be most commonly used to protect service-to-service calls. So if you have a circuit breaker using Hystrix inside your application, and you now want to talk to another service on Cloud Foundry, or you want to talk to some legacy data service that you have in your data center that's running on 10-year-old hardware, Hystrix doesn't know or care the difference, and it's going to work perfectly for you.
So, we actually come up with time, but if you have additional questions, check us out at community.apigee.com. We have created a thread so you can ask additional questions, or if you just want to rant and you think that we're full of shit, just put tell us through the community, and we'll have our diatribe on the community.
Sounds great.
All right, thank you. Oh, actually, one last question. What recommendation do you have regarding distributed transactions across microservices?
I don't know that we're going to be able to handle that.
Don't do it. We'll why don't you ask the question on community, and we'll definitely pick that up.
Sounds good.
Thank you.